Good afternoon to all of you there in Brussels. I didn't quite hear it, but thank you for the introduction, Rob. My apologies for not being there in person due to a scheduling conflict, but I'm certainly there with you in spirit. And I greatly appreciate all of your efforts as well as the efforts of all your colleagues in Biodiversity Genomics Europe. Today, I'm going to give you a brief overview of the progress we are making on scaling the production of reference quality genomes for the understanding of biodiversity. The Earth Biogenome Project is a confederated international network of networks that has the common goal of sequencing and annotating the genomes of approximately 1.6 million named eukaryotic species in 10 years. The EBP will proceed in 3 phases with a sequencing of 10,000 species in phase 1, including a representative species of about 5,000 or half the eukaryotic families and 5,000 other species of scientific interest or bioeconomic importance. Phase 2 will include the collection of 300,000 species and the sequencing of 150,000 species that represent now greater than 90% of the family's total and approximately 50% of the eukaryotic genera. Phase 3 will commence in 2032 after the completion of phase 2 and will include the sequencing of the remaining approximately 1.6 million named eukaryotic species. All of this we have estimated can be done at a total cost of $3.9 billion, which is $800 million less than our original 2018 estimates. And that is due to the improvements in DNA sequencing technology and cost efficiencies that have been gained across the entire sequencing and reference genome production pipeline. I might add at this point that 3.9 billion US dollars today is less than the cost of sequencing the human genome in 1993 dollars. That adjusted to today's dollars is about $6 billion. Obviously, at a cost that's about 2/3 of what the human genome costs, sequencing of biodiversity is probably going to be one of the greatest values in the history of science. The Earth Biogenome Project is a confederated international network of networks and has an elected executive council from its membership and a committee structure that is responsible for the production of standards for the collection and processing of samples, for sequencing and assembly, for annotation, for analysis, and for information technology and informatics. There are also committees for ethics, legal, and social issues, as well as Committee for Justice, Equity, Diversity, and Inclusion. And this overall structure is mirrored in the ERGA structure that has been created for Biodiversity Genomics Europe. At present, there are 60 affiliated projects with more than 2,000 participants located in 88 countries around the world. All of the projects are committed to an open data access model, compliance with the Convention on Biological Diversity and the Nagoya Protocols on access and benefit sharing, and the use of digital sequence information. The Earth Biogenome Project is also committed to diversity, equity, and inclusion within the EBP community of scientists and engagement with indigenous peoples and local communities. The Global Secretariat for the Earth Biogenome Project is located at Arizona State University, with additional support provided by the University of British Columbia and the Wellcome Sanger Institute. As my colleague Mark Blackser, who is in the room with you, likes to say, sequence locally and think globally. As just mentioned, the Earth Biogenome Project is a network of networks. This global network is being nucleated around nodes that coordinate sequencing across a broad geographical area, such as the European continent. In fact, ERGA, the European Reference Genome Alliance, is the first regional node of the Earth Biogenome Project, and some of the major projects and contributors to the EBP are organized under the ERGA regional node, including the Darwin Tree of Life project located at the Wellcome Sanger Institute, the Atlas C project, and the Catalan Initiative for the Earth Biogenome Project, all major contributors to the production of reference quality genomes at global scale. So, what is the current status of the Earth Biogenome Project? The EBP is now past a major milestone of producing more than 4,300 genomes. That represents about 20% of the total number of genomes in public domain databases. If you look at that as a representative of the number of genera, that's about a third of the number of genera and about 44% of the number of genomes for each eukaryotic family. If you look at year-over-year scaling and quality, the EBP affiliated projects have been doubling the number of genomes produced every 2 years. And if you look at the light blue shaded bars, you can see that the largest increase has been in the number of chromosome scale assemblies. The numbers for 2025 only represent the first 8 months, and we fully expect to hit close to 5,000 genomes, about the halfway mark toward phase 1 goal by the end of the year. To reach the phase 2 target, we're going to have to scale more than tenfold the current output globally for genomes. That is a major challenge that the project faces over the next year or two, to understand the requirements and to develop all of the procedures and protocols and obtain the funding to reach the phase 2 goal. One of the most impressive aspects of the Earth Biogenome Project is the fraction of reference quality genomes produced by EBP affiliated projects and the rest of the world. If you look at the data at the species level, EBP affiliated projects have produced more than half of the total of reference quality genomes. At the genus level, it's 60%, and at the family level, it's 70%. Nearly 70% of all reference quality genomes, and we define those as those genomes that would meet the minimum EBP standard metrics, as shown at the bottom of the slide. So I just want to review and finalize my talk by going over a few key points. First, reference quality genomes can be produced at scale. We have demonstrated that now over the past 7 years. And that will enable us to achieve our goal of sequencing all named eukaryotic life in a 10-year time frame. The EBP is an international network of networks that has taken years to build this network. It is now highly integrated and very successful in terms of producing the standards that are necessary for the project and facilitating global interaction and collaboration. And to achieve the goals of phase 2, the regional nodes and the affiliated projects must work together to scale all phases of the production pipeline. And that is going to be the main focus of our activities over the next few years. And as mentioned previously, ERGA is the first EBP regional node that is coordinating production of reference quality genomes on a continental scale across Europe. And ERGA will play a key role in providing solutions for the biodiversity crisis, enhancing the resilience of agriculturally important species, and stimulating a circular bioeconomy. The EBP looks forward to continued leadership of ERGA and of Europe, and I wish you success with all your efforts over the next few days. Thank you very much, and now I'll hand the floor to my colleague Camilla Mazzoni.